Have you ever stopped to wonder what actually makes your coffee maker smart? Or how your car's airbag knows to go off in that exact split second? Well, the answer is a tiny, super powerful brain that's hidden inside pretty much everything you own. And in this explainer, we're going to dive in and find out exactly what it is and how it all works. I mean, seriously, think about it for a sec. A car, a microwave, and a camera. They couldn't be more different from each other, right? One zaps your leftovers, one freezes a moment in time, and the other gets you from A to B. But believe it or not, they all share a secret ingredient. What do you think it is? Yep, you guessed it. The answer is a microcontroller. It's basically an entire computer, the whole shebang, squished onto one tiny little chip. This is the invisible intelligence that makes all of our modern gadgets feel so, well, smart. So to really get a grip on just how huge their impact is, we first need to see how ridiculously widespread these little computers are. You're probably going to be shocked when you realize you've likely used a dozen of them before you even finish your morning coffee. Okay, just let this list sink in for a minute. They are literally everywhere. At home, your TV, the remote, the washing machine, all of them. At the office, they're running the printer and the copier. And in your car? Oh man, that's where they're absolutely mission critical. We're talking engine control, airbags, anti-lock brakes. We are for real living in a world built on top of these hidden systems. All right, so we get it. They're everywhere. But what is one of these tiny brains, really? Let's zoom right in and take a look at what makes a microcontroller tick. Now, the key thing to understand is that this isn't just a processor chip like the one in your laptop. A microcontroller is an all-in-one deal. It has a CPU, sure, but it also has its own built-in memory, both RAM and ROM, plus all the ports it needs to talk to the outside world, and even its own timer. It's a complete, self-sufficient computer system just shrunk down onto a single piece of silicon. And this right here really shows you the difference. On the one hand, you've got your PC processor. It's a beast, a powerhouse, but it needs all these other separate chips just to function. It's powerful, for sure, but also complex and way more expensive. And on the other hand, you have our microcontroller. Everything's baked right in. It's a specialist. It's designed to do one specific job really, really well, and to do it cheaply. You know, it's like you wouldn't use a sledgehammer to hang a picture frame, right? It's just total overkill to use a PC processor to run a microwave. But here's the catch. This tiny computer can't do a single thing by itself. It's just sitting there, waiting. It needs instructions. It needs a program. So the question is, how do we actually talk to this brain on a chip? Now, I know what you're thinking. This looks like absolute gibberish, but this is the chip's native language. It's called assembly. Think of it like a super, super specific recipe. This one line of code is just a single step. It's telling the chip, hey, take this number, 25, and put it in this specific little storage box. Every single complex thing a device does, from brewing your coffee to firing an airbag, is just a long, long list made up of thousands of these tiny, precise steps. And this is where it gets really amazing. So we have these abstract digital commands, right? Just lines of text. How do they actually translate into turning on a light, or spinning a motor, or making your phone buzz? How does the code actually reach out and touch the physical world? It all happens in this incredible chain reaction. First, the code tells the chip to send out a teeny tiny electrical signal. Think of it like a whisper. But that whisper is way too weak to turn on a big lamp. So that tiny signal goes to a driver chip, which acts like an amplifier, turning that whisper into a shout. Now that shout is powerful enough to flip a special kind of electromagnetic switch called a relay. The relay closes, completing a totally separate high-power circuit, and bam, the lamp turns on. A tiny digital command just made a real-world action happen. Okay, so let's pull all this together and zoom back out. We've seen what they are, we've seen how we talk to them and how they interact with the world, but what's the big picture here? What's the main takeaway? The bottom line is this. Even though we never see them, these microcontrollers create an invisible, intelligent layer that literally animates the world around us. They are the tireless, hidden workhorses that take our simple instructions and use them to power the technology that we all depend on every single day. Which leaves us with a pretty fascinating thought to end on. We've managed to put a tiny, programmable brain in almost every object you can imagine, giving them all the ability to sense, to process information, and to act. So the big question for the future is, now that they're all there, what are we going to teach them to do next? Thanks so much for joining me on this deep dive.